In this lesson, you will be writing the equation of the line that passes through the parallel or perpendicular line. Okay, so just a quick review about what is slope-intercept form. Okay, so slope-intercept form is y equals mx plus b. Okay, what is standard form? Standard form is ax plus by is equal to c. Okay, and point slope form is y minus y1 is equal to mx minus x1. Okay, also to negative reciprocals. Okay, so we kind of learned these back in fractions, so just to refresh your memory, the reciprocal of 2/5 would be 5/2. So the negative reciprocal is negative 5/2. Okay, negative reciprocal, negative 7/3. Okay, negative reciprocal here, it already is negative, so the opposite would be positive 2/1, or just 2. And then here we have 3/4. Okay, so for parallel lines never intersect. So if we want to know the slope of the red line, okay, we find a point on the line, okay? So we're here. So if we rise 1 and run 2, on the blue line here we also rise 1 and run 2. Okay, so the slope of each of them is 1/2. So we can see that parallel lines have the same slope. So if we want to determine if these two lines are parallel, we need to put them both into slope-intercept form and compare the m, which is the slope. So this one's already in slope-intercept form. So our slope here is -1/3. So let's check it out on this side. So I want to subtract 2x from both sides. And I'll have 6y is equal to -2x plus 12. Okay, so here then I'm going to divide both sides by 6. So I'll have y is equal to -1/3 x plus 2. Okay, I'm dividing these both by 6. So I see that right here it's -1/3. And my slope here is -1/3. So are these lines parallel? Yes, they are. Because they have the same slope. Okay, so here let's see if these two lines are parallel. Okay, I'm going to do the same thing. Here my slope is 3/4. Now I'm going to try this one by putting it in slope-intercept form. Oops, this is an x. So now I have 8y is equal to -6x minus 24. Divide both sides by 8 to get y alone. So y is equal, 6/8 I can simplify it to 3/4 minus 3. Okay, so here I have -3/4 and here I have 3/4. So these are different slopes. So no, they are not parallel. Okay, so pause the video for a moment and try this one on your own. Okay, so here you should have seen that the slope for this equation is 2/3. Okay, and then over here, if I subtract 4x, to put it in slope-intercept form, I have 6y is equal to -4x minus 2. Dividing both sides by 6, I have y is equal, 4/6 is 2/3, so it's -2/3 minus 1/3. Okay, sorry, there should be an x right here. Okay, so I can look at the slope here, which is -2/3. So no, these are different. The lines are not parallel. Okay, so in this part we want to write the slope-intercept form of the line that contains the point 5,1 and is also parallel to this line. Okay, so in order to do that, we need to first write the equation in point-slope form. Okay, so remember point-slope form. I'm going to use the points here, which is y minus y1 is equal to mx minus x1. Okay, so parallel lines have the same slope. Okay, so I'm going to use this slope right here. But I'm going to use these points because I want it to be on this line with the same slope. Okay, so y minus 1 is equal to 3/5 x minus 5. Okay, so I'm not done yet. Now I need to transfer this into slope-intercept form. So I can distribute. Okay, 3/5 times negative 5 is negative 15 over 5, which is negative 3. Okay, then I'm going to add 1 to both sides. And I get y is equal to 3/5 x. Negative 3 plus 1 is negative 2. Okay, so here is my line that is parallel to this line, and it includes the point 5, 1. Okay, so pause the video for a moment and try this one on your own and check it back. Okay, so the first thing that we want to do is we want to have the same slope, which is m. Okay, and then we're going to use the point 2, negative 6 to put it into point slope form. So y minus negative 6, which is y plus 6, is equal to the slope times x minus 2. Okay, remember that this is x1 and y1. Okay, now I need to change this into slope-intercept form. 3 times x and 3 times negative 2. Okay, now to get y alone, I have y is equal to 3x minus 12. Okay, so here is the line that is parallel to this line because they have the same slope, okay, and it includes the point 2, negative 6. Okay, so kind of going in the opposite direction here, we're going to talk about perpendicular lines, okay? So perpendicular lines are lines that intersect to form a right angle. So right here, forming a right angle. Here, here, and here, okay? So right here, if I want to know the slope of the red line, okay, here's the red line. If I rise 1 and run negative 4, okay, so negative 1/4. The slope of the blue line, if I'm starting here, if I go down 4 and to the left 4, I'm going negative 4 over negative 1, which is positive 4, okay? Notice that the slopes are negative reciprocals. Okay, so if I want to know the slope of the line that's perpendicular, if this slope is 2/5, the perpendicular line will be negative 5 over 2. Okay, so again, the negative reciprocal slope of negative 1/5 would be 5. Okay, so let's determine if these lines are perpendicular. So we want to put them both into slope-intercept form, just like we did with the parallel, okay? So if I subtract 2x here, I have 3y equals negative 2x plus 4. Divide them both by 3. So now I have y is equal to negative 2/3 x plus 4/3. Okay, so here I have this one in slope-intercept and this one. So now let's look at the actual slope. 2/3 and negative 2/3. Okay, these are not negative reciprocals. So no, these lines are not perpendicular. Okay, so for the second one, try this one on your own, so pause the video for a moment. Okay, so here you should have subtracted 3x to get y alone. So 4y is equal to negative 3x plus 9. Then I'm going to divide both sides by 4. So I have y is equal to negative 3/4 x plus 9/4. Okay? So here is one equation, and here is the other. Now if I look at the slope, 4/3, negative 3/4. Okay? Yes, these are negative reciprocals, so yes, they are perpendicular. Okay, so to find the equation of the perpendicular line, okay, we're going to do the same thing that we did for parallel lines, except we're going to change up the slope a little bit to make it negative reciprocal. Okay, so here I'm going to use 0, -2 as my x1, y1. Okay, but now my slope, instead of 5, the negative reciprocal is -1/5. Okay, so I'm going to plug these into point slope form. So y plus 2, because it's -2, is equal to -1/5 times x minus 0. Okay, so in this case, when we distribute, this becomes -1/5 x. And then -1/5 times 0 is just 0. So on the left side, it's y plus 2. Okay? So now I want to put this in slope-intercept form. So if I subtract 2 from both sides, I'll have y is equal to -1/5 x minus 2. So if we look at the equation that we just came up with, this line right here is perpendicular to the original line because the slopes are negative reciprocal. And this line that I just made contains the point 0, -2. Okay, so pause the video for a moment and try this one on your own, just like the one before. Okay, so if we look at the slope here, we have 3/4. So the perpendicular slope is going to be -4/3. And the 2 points I'm using are 1 and 8. This is my x1 and my y1. Okay, so plugging into point slope form, I have y minus 8 is equal to my new slope, -4/3 x minus 1. Okay, so now I need to change this into slope-intercept. So -4/3 x, -4/3 times -1 will give me +4/3, which is equal to y minus 8. Okay, last step is to add 8 to both sides. Okay, so here if I want to add 8, I need to change it into thirds. So that's going to be 24/3. So instead of that, I'm going to put 24/3. So now I have y is equal to -4/3 x plus 4 plus 24 is 28/3. Okay, so you can write it like this. Okay, or if you would like, if you want to divide 28 divided by 3, you would get 9.3, or written like this. Okay, so these equations that we just made right here are perpendicular to the original, and they include the point 1, 8.